Hello everyone, in today's video we'll be learning about the experiment Jominy and Quench test, also known as the hardenability test. Let us first know what is hardenability. Hardenability of steel is the measure of capacity of steel to harden in depth under a given set of conditions. It is the ability of iron carbon alloy to be hardened by forming martensite. The aim of the experiment is to determine the hardenability of steels. The apparatus used are high temperature furnace, end quenching setup, and Rockwell hardness tester. The specimen used is high carbon steel. This is the flowchart of the procedure. We take room temperature steel, which is of BCC structure, body centered cubic. It is heated in a furnace to a temperature of 800 degrees centigrade. At this temperature, austenite is formed, FCC, face centered cubic structure. Austenite ranges from a temperature of 727 degrees centigrade and 1493 degrees centigrade. Hence, we choose a temperature of 800 degrees centigrade. After this, austenite form of steel is taken out of the furnace and quenched. Quenching is rapid cooling by immersion in oil or water or only air of a metal object from the high temperature at which it has been shaped. Therefore, austenite is water quenched and air quenched. One side is water sprayed, which is water quenched, thus forming martensite of BCT structure, body centered tetragonal. The other side of the specimen is air quenched or left open to the atmosphere, with forming perlite, which has a layered microstructure. The left hand side of the picture shows the quenching setup. As we can see, water is sprayed on the bottom of the specimen and the top part of the specimen is open to air. Thus, martensite forms the hardest form of steel and perlite is relatively softer than martensite. Here we can see the body centered tetragonal crystal structure of martensite. This is a picture of micro level structure of martensite and perlite. Now we need to test the hardness of the specimen quenched. So we use the Rockwell hardness test. The principle of this test is that a standard load is applied through a standard intender for a standard duration of time. The hardness number is directly obtained from the instrument. But what is hardness? Hardness of a material is defined as the resistance to permanent indentation, penetration, or deformation under static and dynamic loads. So, for example, a steel of high hardenability can transform to a high fraction of martensite to depths of several millimeters under relatively slow cooling, such as an oil quench, whereas a steel of low hardenability may only form a high fraction of martensite to a depth of less than a millimeter even under rapid cooling of water quench. But why exactly does it form martensite? This is because the carbon atoms do not have time to diffuse out of the crystal structure in large enough quantities to form cementite, which is Fe3C. Here we can see that the hardness value of the water quench side, which forming martensite, is higher than perlite, which is a relatively softer side, and hence this is the graph we obtain. Some other important specifications are that the specimen of high carbon steel is of cylindrical shape, having diameter 25 mm and length 100 mm. Ramp is 10 degrees centigrade per minute. This denotes that every minute the furnace temperature raises itself by 10 degrees. Dwell time is 60 minutes, indicating that once the furnace reaches its final temperature, it will be at the constant temperature for that amount of time. And the final temperature here is 800 degrees centigrade. So put together, it means that once the furnace reaches 800 degrees centigrade, it will be at that constant temperature for 1 hour. The intender used in Rockwell hardness test is of cone shape of 120 degrees and made up of black diamond. And why is this test important? It is to be able to select the appropriate combination of alloy steel and heat treatment to manufacture components of different sizes to minimize thermal stresses and distortion. Thank you all.